Welcome to another video and episode on my Raspberry Pi 1 running Raspbian Linux. Stacked upon the Raspberry Pi is the Zero Pi Plus, which connects to serial cable, or I did one, and also connected is the RaspberryPi, which is pointed seemingly very down, but due to the high resolution it is pointing towards this breadboard. Then also connected to it is network cable for VNC, virtual network computing, and then, as you could see, this band cable to this breadboard. Also connected, or more appropriately also inserted into the Raspberry Pi is a SD micro card, or micro SD card actually, on which Raspbian Linux is installed. Last time I managed to get the algorithm with the switch running, although little is being seen other than this LED flashing, and I did a little modification. So right now the switch can be seen better. Switch pressed, LED lighting up. And if everything works here with all the wiring, this LED works as an 8th LED. Does it work? Probably. But the big question is, and that turned out to be a big question last time, how do I change the algorithm so it doesn't count up like this, but counts down like that? I did a start last time, but that didn't work out so well, so I need to go on with that. Does that can it be influenced by the switch? Well, I am not quite sure yet. The point is that originally the algorithm goes from 0 to 1024, or more appropriately 1000. It counts to 1024 counted, and I brought it down to 256. But let's see if it runs. Well, it does run, but and this is an problem again, because I don't see any lights running, which is not for the first time, I'm afraid. So let's see what I can do about it. Right now, see, one LED is running. But why only that LED? That is not nice. Okay, let me restart the algorithm. The oscilloscope shows a nice signal, so it does work. And then here and there an LED goes. But it's not what I want to see. Although it may be that it is really the algorithm as I programmed it now. So let's take a look at that and see how things really do. So this is the algorithm. This is the current state of the algorithm. Raspberry Pi camera view. LED number 8. LED with the switch. And band cable. Once again, the problem that I suddenly have with this media player, or with the view anyway, is that it suddenly, well, that happened last time for some reason, it's no longer full screen. Yeah, I can go full screen, but it's not screen filling then. So what the reason is that it's not screen filling, I do not know. It is running here, and rest I have no idea. But that is not the point. The point is right here. Let me put down the camera a bit. This is what you want to see. What I want to see as well. Okay, so how to continue? Well, considering the fact that, oh, now this LED and that LED is burning or flashing, which one is doing what? So this is 2 binnen 4 4. So it is doing this this part of the algorithm. Is it really working what I want to see? So right now, okay, this one is blinking, this one is blinking, and that one is blinking. Now this one shortly, and I would have hoped that this one would blink, the third green one, but right now I don't see anything of those. Ah, the red one blinking again. So right now it's a kind of a mess. Let's zero 16 064 128 00. Doesn't make any sense. And then this one and that one again. This one and those two. So what else goes now? I think my algorithm is a mess right now. So 100 plus bit. This counts down. But what does this do? This is Y. And Y is right now 208. Plus 1 shifted bit is 1 to the power number of bits. So this must be an address then, and this is the value. Oh wait, I have made a mistake here. Now I see. It's not the same. This and this are opposite numbers. So let me change that one. Alright, now they are equal. So I need to recompile. That is better. Okay. Interrupt. Go. So what happens now? Apart from the signal that is going through, I do not see anything oh, wait, I see LEDs. Well, I see one LED, two LED, another one. So what happens next? What are the values anyway? Okay, let's pause it a bit. 0, 2, 4. Oh, that's the normal one. And here we get 2 billion is 0, 0, 0, 0, 0, 0. That doesn't make sense. Also this one. The next one for 2 billion, which is this part, is also all 0. And what is the difference between the normal one? Also all 0. So, okay, let's press a switch, because that is also part of it. Yeah, that works, but what does it has button pressed? Yeah, it doesn't influence the whole algorithm yet, because this part is button pressed, this one is button released, and only here something with the LEDs go on. Still is the question, what does the algorithm do exactly? Alright, let me disable this part of the algorithm for now. Ooh, that's not going wrong. Right. 1 and that is 2. No, not true. I have to do it here, because this is indicating a comment block in C, but it is this block that I should comment out. So yeah, let's compile this and see how the code goes. Okay, right, compile and go again. Run. What does it do? Absolutely nothing. Yeah, right now it does. So this is the original algorithm. Oh, that's funny, which is not funny at all. This is actually quite strange. So when it should go on, it goes off, and when it should be off, it is on. Now it's on again. Now let's see if it counts up until the next green LED. What happens to the red LED? It's off. Oh, that's not good. This one should be burning now. Why isn't it? And I honestly dare not touch these wires because it's working now. I can change the time base, although that doesn't really matter. What does matter is why are LEDs not burning correctly. Okay, big question. Anyway, the algorithm works. So why isn't this one working? So you count down, logic will end here, and how can I make sure that I see whatever is happening? Bit is going down while Y is going up until a certain value. So actually, to get a better understanding, what is this actually look like? I should make something that does this performance. Let's see whatever this is. So 124. Ampersand. So logical end with, and what is this? That's a good question. I can actually, of course, make it quite simple. Very simple actually. I print the Y anyway. Then I print the bit. And nothing keeps me from printing just the one, just this part, apart from that. So let's see, this one. So I first get, no, that's not correct, this is correct. So first I get this shifting number, and then I get everything. I think that's a much better way to check whatever happens. Let's see. Alright. Go. So the first number is 32, and okay, let's stop. Hold on, y is 2, and here I get the full numbers. So this is a bit weird. It's 1, 2, 4, 8, 16. Yeah, okay. So that is indeed what I expected. The first number is indeed doubling. That is the shift. What you expect. And ending gives a 0. So what is this one doing? What is it doing here? Okay, and recompile. Okay, execute. You get actually nothing. You actually do get absolutely nothing with this one. So that means with 2 zeros it doesn't do anything. Ouch! My algorithm thought the whole thing that I thought to do gives nothing at all. I have to rethink my algorithm. Oops. After some experimenting, some foolish thoughts, etc., I came down to this nonsense result. But I then realized I forgot something, because this is counting up from 0 to 255. What if I count down from 265 to 0? And then do the thing. Haven't tested yet, but that's the fun with experimenting. Ah, wait. I am missing something somewhere. Yep, I do. I should actually add this, which is better. A lot better. Function main expected something before something else. Yeah, here. This works better. And this is the advantage of a compiler like for C or C++ or whichever language. You get an error as soon as there is something wrong before you can run it. On the other hand, getting an error doesn't necessarily mean the error is where it is indicated. It can be a very tough searching for the error. Anyway, In the few in the little time that I have still left, let's go see whatever happens this time. Alright. Well, I can press a button, but that is of no influence. The algorithm just goes on because it's just doing this. It's not changing into here. So let's first get this right and then change the algorithm that the button pressed is doing this part and button not pressed is doing this part, for example. Now also let's see. Oh, my network stream has stopped. Now it's working again. And you can't see whatever is happening, although here you can see not really much is happening at all. So now I'm not quite sure. Yeah, there are some LEDs lit up. 3 in total, as you can see. And Y is how much? 1/6. So that will take a bit of time. And here it is. Yeah, what is what? A good question. Well, this is the first one, and 0, yeah, it looks like it's counting. But once again, as long as this doesn't change, it's not counting much. But it's time to wrap up. Yes. And that is it for now. So what did I achieve? Well, apart from this slight modification to the switch, changes for the algorithm, and not yet bringing what I like, what I want to see, but that's the fun of experimenting. So for now, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion what I should do, what I could do, what I should have done, whatever. You can also follow me on Twitter. Please retweet, like it, leave a comment. You can also follow me on Instagram. Please like it, leave a comment. And you can find the URL of my website, as well as for Twitter and Instagram, in the description box under this video. You can show your support by making a small donation via Wired or PayPal. More information on my website. You can also choose to become a patron and have your name mentioned as a supporter. Depend on my website, or on my website as well as in my videos, depending on the pledge you make. For more information, see my website as well as my Patreon page. And obviously this is going to be continued. Thanks for watching, and bye bye.